Imagine standing at a crossroads. Ahead of you are countless paths, each representing a choice, an opportunity, a possibility. In the classical world of computing, you're forced to pick just one path at a time, meticulously exploring each option step by step. It's slow, deliberate, and predictable. But what if I told you there's a way to explore all the paths simultaneously? A way to harness the power of possibility itself. This is the heart of quantum computing, and at the center of it all lies something truly remarkable: the Hadamard Transformation. What is the Hadamard Transformation? Let's start with the basics. In the classical world, our computers think in bits, zeros, and ones. It's a simple on-off system, but in the quantum world, we think bigger. We use qubits, which can exist in a state of 0, 1, or something far more magical, a superposition of both. The Hadamard Transformation is what makes this magic possible. Picture this. You start with a qubit in a single state, say 0. You apply the Hadamard Transformation and suddenly, that qubit isn't just 0 anymore, it's not just 1 either. It's in a perfect balance of both, like a coin spinning in midair, neither heads nor tails but something in between. This is superposition, and it's the foundation of quantum computing. Now here's where it gets truly exciting. The Hadamard Transformation doesn't just stop at one qubit. Imagine you have multiple qubits, each representing a decision. When you apply the Hadamard transform to all of them, it creates a vast, shimmering web of possibilities, a superposition of every possible outcome. Let me put this into perspective. With just 3 qubits, you can represent 8 possibilities, 2 to the power of 3. With 10 qubits, that number jumps to over 1,000. And with 300 qubits, you're looking at more possibilities than there are atoms in the observable universe. This is the power of the Hadamard Transformation. It doesn't just compute, it expands your reality. But wait, there's more. The Hadamard Transformation doesn't just create possibilities, it aligns them. It's like an orchestra conductor, ensuring that every note, every possibility, is perfectly in sync. This balance is what allows quantum algorithms to work their magic. It's what makes it possible to amplify the right answers while canceling out the wrong ones. Think about that for a moment. In the classical world, computing is often messy, chaotic, and noisy. But with the Hadamard Transformation, everything is balanced, beautiful, and precise. Now you might be asking, why should I care? Here's why. The Hadamard Transformation isn't just math, it's a paradigm shift. It's the key to solving problems that are too complex, too vast, and too interconnected for classical computers to handle. With the Hadamard Transformation, we can factor massive numbers, unlock unbreakable codes, optimize global logistics, and even simulate the behavior of molecules for groundbreaking medical research. It's not just faster, it's smarter. Finally, I want you to think about the Hadamard Transformation as more than just a tool for quantum computing. It's a reminder of something profound, that the best solutions often come from seeing the world differently, from embracing the possibilities instead of picking just one, from finding balance in chaos. The Hadamard Transformation teaches us that innovation isn't about following one path, it's about creating new ones, and exploring them all at once. The Hadamard Transformation is more than just an operation, it's a story about how we're redefining what's possible, a story about simplicity, beauty, and the limitless potential of the quantum world. And that, my friends, is not just the future of computing, it's the future of humanity.